everyone. Myself Prayak Patel, working as Assistant Professor in IT ICT Department of LJ Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the next topic of graph theory as a combinations. Now we already know the permutation in our previous lecture. So what is the combination? Now here in combination, the number of way of choosing R elements from the S elements. So here given set S is like this 1, 2, 3. So in a set we have a 3 element. Now R means consider the number of sub elements choice from the S elements. So number of way possible for choosing the R elements. So here for example we consider R equal to 2. That means we have to select 2 element from the available 3 element. So for the given set S, combination of 2 element is like this 1 2, 1 3 and 2 3. Now here we can say that the 3 combination is possible for this set. Here we consider 1 2 3 as a set. 1 2 as a 1 element in permutation. In permutation we consider 2 1 as another element, but here we consider the 1 2 is same as 2 1. So no need to worry about the 2 1. So here only we consider the number of element is different element. No consider the order. Order is not matter in the combination. Now here the number of R combinations C and R of a set with n equal to mod S. That means n element available in a set. Then this representation, this combination is represented using this equation. C of nr equal to nr. Or we can say that the another way as a n factorial divided by r factorial into n minus r factorial. So this is a combination for the n element as a given element, and we have to combine the element as a r element, combination of r element. Now here we already know the binomial theorem, calculating binomial coefficient. So for this we can find the C of nr. So here what is the meaning of n? N means number of rows. So 0, 1, 2, 3 up to n row available as a number of rows. Now after that consider the column number as a 0, 1, 2, 3 up to r column. Now common equation for this C of nr equal to, here we can say that the last block consider as a C of nr. Now for that, what is the equation for C of nr in calculating binomial coefficient? So equation is like C of n minus 1 r minus 1 plus C of n minus 1 r. So combination of upper block and left block, addition of these two block is become a C of nr. So for that we can consider the initial condition for this is if r equal to 0 then our result is 1. If r equal to n then our result is 1. That means here first column become a 1. 0 column consider as a 1 value. Now same way 1 1, 2 2, 3 3, 4 4 up to r all are considered as a same value n equal to r. That means this diagonal is also considered the value as a 1. Now after that how we can find the value of each and every remaining element? So for that here for the location 2 1 we find the value 2 1 from addition of upper two element. That means addition of 1 plus 1 equal to 2. After that next value is a 1 plus 2 equal to 3, next value is a 2 plus 1 equal to 3, next is a 1 plus 3 equal to 4, then 3 plus 3 equal to 6, then 3 plus 1 equal to 4. So this is a combination. Here we can say that the different way possible for selecting the element from available n elements. So for example here we consider the for 2, that means 4 element available in a set. From the 4 element we have to select only 2 elements, then for 2 n equal to 4 r equal to 2. So for 2 combination answer equal to 6. That means 6 different possibilities for selecting the 2 element from the available 4 element. Now in previous example we find the 2 element from the 3 element. That means 3 2 table location 3 2 third row second column value is 3. So 1 2 2 3 and 1 3 like this. So this is a simple combination. Now another thing in this table is, first thing is n0 equal to 1, second thing is nn equal to 1, Now what about the remaining location? So for the remaining location, for example, here we can say that the n1. What is the value of n1? Remember this. n1 value is equal to n. C of n1 equal to n. That means here for second row, value 2, third row, value 3, fourth row, value 4 for the first column. Same way, for the n minus 1 location also this is a same value. That means here for value for the location for 1. Also for value for the location for 3. That means n minus 1 location's value is also n and first location value is also n. Remember this point for the combinations. Now here example of the combination is, here we can say the first example. The standard deck of playing cards consisting of 52 cards. Here 52 cards of 4 types. First is clubs, then diamonds, then heart and spades. So all 4 types of card is available. Now for each and every type. For example, for the clubs, we have a 13 card. For the diamond, we have a 13 card like this for all the 4 types. Now different 30 card is like, for example, we can say that the Ekka, 2, 3, 9, 10, then Jack, Queen and King. So these 13 are different element for the each type. Now our question is, if we are asked to draw the 3 cards, we have to select the 3 cards from the available 52 cards. So here without replacement we have to select the element. That means we have to select 3 cards from the available cards. So what is the combination are possible? What is the probability for that? So for example, we can say that when we select the first card, then total 52 card available. So from the 52 card we can select the 1 card. Now after selecting the first card, we have a 51 possibilities because we already select the 1 card. So for the next selection we have only 51 possibilities. Now after selecting 2 cards, we have a remaining 50 cards. So our probability for third card selection equal to 50. So answer is 52 multiply 51 multiply 50 equal to, we can say this in another way, 52 factorial divided by 49 factorial. So is equal to P of 52 3. Now this is a simple example of the combinations. Now in this example, if we select the 3 cards like AH means Ekka of hearts, 9C means 9s of clubs, KD means king of diamond. If we select these 3 cards, then what is the resultant value? So resultant value is same as our previous case. If instead we simply select the 3 cards at one time from the available deck, then order of selection of the card is no longer important, because here we select first as a AH, second as a 9C and third as a KD. If we change this sequence, then no any matter, because here we have to only select the 3 cards. In which sequence is not matter. That's why we can say that it is a combination, not as a permutation. So in permutation we consider the order is matter, but in combination no order is matter. That's why if we select the AH, 9C, KD, if another sequence is AH, KD, 9C, another sequence is 9C, AH, KD, this all the sequence is considered as a equivalent. No any difference in this all, because finally we select these 3 cards. So consecutively we can say that each selections or combination of these 3 cards with no reference or no repetitions of order, then we can consider the corresponding to 3 factorial value. Now after that, here this equation is translated into this form like 3 factorial, because we select the 3 cards, so we write the 3 factorial, multiply number of selection of size 3 from a deck of 52. That means the combination of the 3 from the 52 cards equal to number of permutations of the size 3 for the 52 cards. So permutation is equal to 3 factorial into number of combinations. So here simply we can say that permutation equation is equal to P of 52 3. Now what is the value of this? 52 divided by 49 according to permutation formula. So here 52 multiply 51 multiply 50 is equal to 132,600 ways. Now, if we want to find the combinations, then number of selections of size 3 from the deck of 52. If you want to find the 3 card from the 52 cards, then what is the combinations? So 52 factorial divided by 49 factorial is considered as a permutation. Now here equation is 3 factorial into number of combination equal to number of permutation. That means divided by 3 factorial. So final answer is 52 factorial divided by 3 factorial into 49 factorial. So answer is 22100 ways. So this last answer is considered as a combination possible for the selecting 3 cards. And first answer considered as a number of permutation possible for selecting the 3 cards. Now here common formula for the combination. If we start with the n distinct objects, each selections or combinations of R of these objects with no reference to order correspond to R factorial. Permutations of size R from the n objects. So here the number of combination of size R from a available element of n element. So collection of size n element and we have to select only R element. In this equation, we see that C of nr, that means combination of nr, available element as a n element, and we have to select only R element from the available n element. So what is the combination of that? What is the number of combination? So here is equal to, we can say that the P of nr divided by R factorial. So P of nr, that means from here we can say that the P of nr means n factorial upon R minus n minus R factorial. So final equation for the combination is n factorial divided by R factorial into n minus R factorial for the value of R and n is 0 less or equal to R less or equal to n. So this is a common formula for the combinations. Now here in this formula, what is the different value? What is the different possibilities for n and R? Here we write the C of nr in another form as a nr in bracket. Here we read this statement is like n choose from R. N choose R, that means R element chosen from the nth element. Now for the value of n greater or equal to 0, C of n 0, that means R equal to 0. Then value is equal to 1. If R equal to n, then C of n equal to 1. That means C of n 0 equal to C of n equal to 1. Now another. For all n greater or equal to 1, C of n1 equal to C of n minus 1 equal to n. We already discussed this point. If we consider the first column in Pascal triangle, then it is considered as a value n. If we consider the second last column, that means the n minus 1 element, it is also considered as a n value. So this is a common value for this value. Now for the value greater than n, R value is greater than n, then we can say that the 0 less or equal to n less than R. Then C of nr equal to nr equal to 0. That means if we have an n element is available and we have to perform the combination of R element and R is greater than n, then this type of no any combination is possible. That's why our answer is equal to 0. Now comparison of the combination and permutation. Whenever we are dealing with the counting problems, we should ask ourselves about the importance of order in the problem or not. So here order is important or not is a first question in ourselves. Here first thing, when order is relevant, we think it term as a permutations and arrange this term in form of the rule of product. Now second is when order is not relevant, then combinations are considered here. So combinations could play a key role in solving this type of problem. So order is matter, that means permutation. Order is not matter, then this is called the combinations. Now consider some example of the combinations. Now here first example, a hostess is having a dinner party for some members of her charity committee. So she want to give the party for the committee members. Now because of the size of her home, she can invite only 11 of the 20 committee members. So total 20 committee member in a committee, but because of the size of the home, she invite only 11 member out of the 20. So here order is not important because randomly we have to select only 11 element in any order. Order is not important here. So we can say that this is example of combination. So first you think about this example is about combination or permutation. Now here, so she can invite the luckily 11 member in form of C of 20 11 because total n equal to 20 and r equal to 11. So C of nr equal to C of 20 11 equal to, we can say that the 20 factorial divided by, here equation is n factorial divided by r factorial into n minus r factorial. So 20 factorial divided by 11 factorial into 9 factorial. So total way possible is 167960. Now here see the another thing in this example. A student taking a history examination is directly to answer the any 7 question of 10 easy questions. So total 10 question available in a question paper and student have to give the answer of easy 7 question. So see here what is the combination possible for that. There is no consider as a no any another thing is given here. So only 7 question is selected from the available 10 question according to individual students. So here how many number of combination is possible? So 10 is a total number and r equal to 7, you have to select 7 paper. So 10 7 C of 10 7 is equal to 10 factorial divided by 7 factorial into 3 factorial. So here 10 multiply 9 multiply 8 divided by 3 multiply 2 multiply 1, because here in 10 factorial and 7 factorial we remove the 7 factorial from the 10, then remaining as a 10 9 and 8 is equal to 120 ways. Now in this example, if we add something in this example, then if the student must answer the 3 questions from the first 5 and 4 questions from the last 5, our given scenario is like this, then what is the combination? So for the first 3 questions selected from the available first 5 questions. So combination is 5 3, C of 5 3 is equal to 5 factorial divided by 3 factorial into 2 factorial. So is equal to 5 cross 4 divided by 2 cross 4 is equal to 10 different ways. Now for the another selection, 4 questions selected from the available last 5 questions. That means C of 5 4 is equal to 5 factorial divided by 4 factorial into 1 factorial is equal to 5 by 1 equal to 5 ways. Now what is the total probability, total combination possible for this giving the answer of the question paper? So here by the rule of product, the student can complete the examination in how many ways? So here multiply both the ways, 5 into 3 then 5 and 4. So 10 way possible for the first 3 question, 5 way possible for the last 5 question. So here we can say that the 5 3 into 5 4, that means 10 into 5 equal to 15 different ways for giving the exam according to this condition. Now in this question, if we add something, finally, should the directions of the examination indicate that the student must answer the 7 of 20 questions where at least 3 are selected from the first 5. So your criteria is you have to compulsorily select the 3 questions, minimum 3 questions, at least 3 questions from the first 5. Then what is the here combination? Now first case, the student answered the 3 of 5 questions and 4 of last 5 questions, because here at least 3 questions, that means student can select the 3 questions from first 5, student can select the 4 questions from first 5, student can select the 5 questions from first 5, because here given data is at least 3. So see here, first case, if student give the answer of 3 questions from first 5 then 4 from the last 5, so combination is 10 into 5 equal to 50 ways in according to previous case. Now second case, 4 questions, give the answer of 4 questions from the first 5, then first combination is 5 4, from the 5 questions give the answer of 4. Second combination is 5 3, that means remaining 3 questions selected from the last 5. So final answer is 5 into 10 equal to 50 ways. Now third possibility. The student decide to answer all the first 5 questions, then remaining only 2 questions from the last 5. So answer is 5 into 5 2. That means 1 into 10 equal to 10 different ways. Now if we combine these 3 steps, combine the case 1, case 2 and 3. By rule of the sum, we find the student can make the exam like first case plus second case plus third case. So 50 plus 50 plus 10 equal to 110 total possibilities for giving the answer of these questions according to our 3 cases. So this is the final answer for this exam. Now here consider the another example. In a high school, the gym teacher must select the 9 girls from the junior and senior class for the volleyball team. So here you have to make a team of 9 students, of a 9 girls. So here what is the probability of this? So here how many number of junior student and how many number of senior student are available? So 28 junior student and 25 as a senior student. Now you have to make a team of 9 students. Then total number of student equal to 53 and you have to select only 9. Then 53 9. That means C 53 9. That means 4 4 3 1 6 1 3 5 5 0 ways are possible. Now see here another scenario. If 2 juniors and 1 seniors are the best spikers and must be selected in this team, that means 3 student is selected by default, then how many remaining student are there? So total remaining student equal to 50 and you have to select only 6 student from the 50. So our scenario is like C of 56. Then answer is 15890,700 ways. Now see here we select these different student from this team according to 6 student and you have to combine this 6 student with already selected 3 student. For a certain tournament, the team must selected according to 4 junior and 5 seniors. So you have to select the 4 student from the juniors and 5 student from the senior. Then what is the probability? So for that we can say that the 28 junior are available. So from the 28 you have to select 4 and from the 25 you have to select 5. So this combination is C of 28 4 and C of 25 5. So after that multiplication of these two is considered as a final answer. So multiply these two, then we will get the answer as a 1087836,750 base for this particular tournament. Now after that, here we consider the example as the gym teacher must make up a 4 volleyball team of the 9 girls each from the 36 girls. So here you have to make the 4 team of 9 students. That means we can say that the team name as A, B, C, D. So you have to select the team A as a 9 member, team B having a 9 member, team C having a 9 member and team D having a 9 member. So you have to select the team A according to 36, select 9 element from the 36. Select 9 student from the 36. So C of 36 9. For the selecting the team B, our scenario is select the 9 student from the 27 because we already select the 9 students. So no any common student in any two teams. So here 27 9 is a second possibility for team B. Now for the team C, we select the remaining 80 students and 9. That means C of 18 9. And for this team D, we have to select the 9 out of 9. So this 4 case is considered as a different selection of the team according to A, B, C, D. So final answer is multiplication of this 4. That means 36 9, 27 9, 18 9 and 9 9. So answer is for 36 9. That means 36 factorial divided by 9 factorial into 27 factorial. For the second also same way we can find the factorial for all. So final answer is 36 factorial divided by 9 factorial, 9 factorial, 9 factorial, 9 factorial. And answer is 2.145 multiply with the 10 raised to 19. Now in another way we can consider this team as a combination of 9 students from the available 36 students. So choice is like this: first student, then second student, then third student up to the 36th student. Now we know the each and every team having a 9 student. So A repeated 9 times. B repeated 9 times, C repeated 9 times, and D also repeated 9 times. So according to repetition rule, we can combine this factor as a 36 factorial divided by 9 factorial into 9 factorial into 9 factorial into 9 factorial, because we have to select total n equal to 36 and A repeated 9 times, so first 9 factorial, then 9 factorial, 9 factorial, like this. So final answer is same for the both the case. So you can find the answer according to any method. Now in this lecture we discuss about the what is combination and how we can find the answer of the combination from the available n element, and you have to select only r element from the available n elements. Thank you for watching this video.